We measure a lot of things, starting from something like mass of an electron, mass of earth, speed of light, speed of sound in air, how money a person has, the wealth they have, height of a person, the amount of food we eat. We measure everything, is it not? So when it comes to measuring something like height of a person or length of a table or how big a phone screen is, we just use normal centimeter, in some cases meter, in some cases kilometer, right? Like in the case of speed of sound in air, the last one, it's 343 approximately meter per second. But when it comes to measuring things like mass of an electron, mass of earth, mass of sun, right, speed of light, we need to use some representation like this. Of course, there is the 9 and the 5 and the 3 as well, but this is also very important. So what does it mean and how does it help? So why do we need it? So to understand all of this, we're going to start off with a topic called exponents. So what is it basically? What is that we're going to talk about it and how is it useful and everything? Let's start off with this set of videos. So what is it? First question is, what is it? See, the idea of adding same number repeatedly is nothing but what? Is, yes, multiplication. So if I'm adding 12 32 times, it's equal to 12 into 32. Right? But what if I want to multiply same number a particular set of times? See, I'm multiplying, not adding, multiplying. So we need a representation for that as well. So that representation is done with the help of exponents, wherein we write 12, and to indicate that it's being multiplied 32 times, we're going to write 32 over here at the top. Right? So repeated addition is dealt with multiplication and repeated multiplication is dealt with exponents. So what is the basic definition of exponents? Exponent of a number, this is number, tells how many times it, that is the number, has to be multiplied. For example, 15 to the power of 3. It is nothing but 15 into 15 into 15. 16 to the power of 5. 16 into 16 into 16 into 16 into 16. Okay, 16 and I have written some 3 over here. 15 and I have written 3 over here. 16 I have written 5 over here. So it tells that 15 has to be multiplied repeatedly with itself 3 times. Right? It's not same as 15 into 3. This is not same as 15 into 3. Remember. Because again, this is a common mistake. People do it when they are in a hurry. And this, the next one, is not same as 16 into 5. So one more way of understanding this is, if I have a particular number multiplied particular number of times, I just have to write that number, and at the top I have to write the number of times it's being multiplied. It's the same with the negative number also. Here negative 40 is being multiplied 143 times. Negative 40, put a bracket, because any negative term, brackets has to be part of it. I told you guys, be careful with negative terms. So I wrote minus 40, negative 40 and a bracket, and at the top 143. So the first thing before we start off doing anything with exponents, it's to know how to read it. Example, 5 to the power of 3. This is read as 5 to the power of 3. This is one of the ways. There are quite a few ways. There's no particular method that you need to use for a particular problem in reading, that is. So you can read quite a few ways. So this is, I think this is convenient. Whatever is convenient to you guys, you can use that. So the next one is minus 10 to the power of, or raised to the power of 5. Minus 2 by 3 to the power of what? 14. A to the power of 4. So yes, we can use exponents to represent that a variable is getting multiplied particular number of times. So when it comes to reading exponent, we have few cases. That is, you read this as 15 to the power of 2, that is also good, or 15 square. This you read it as negative 46 to the power of 3 or negative 46 cube. Okay, quite simple. Next, there are a few more names that you need to know, because again, when I'm teaching exponents, I'll be using these words. So you need to understand what does that mean, right? I can't use a word and if you don't know that, you won't be able to understand. So now, till now we have seen that we have written numbers over here and here, or variables or anything. So if I write a number over here, that number is called the base. And at the top, it is known as the power. Any number or variable can be written. So in this place, I can write a variable, and here also I can write a variable. So here the base is A and the power is B. Okay, or I can write a number or a number, or it can be combination of variable or number, doesn't matter. So let me add a okay, so yeah, I will show you a few examples wherein we'll discuss what is the base and its respective power. Here the base is negative 7 and the power is 3. Here the base is 10 and the power is 4. Here the base is 6 and the power is 4 by 3. No, right? The base is 4 by 3 and the power is 6. And the next one, the base is 7 by 3 and the power is 4. Wrong. The power is negative 4 because it's negative 4. There's no because. But what does it mean? You will not come across negative any power as of now. What does it mean? Well, we'll learn that in some time. So the meaning of negative powers. The next one, the base is A, the power is negative B, right? So I just need a minute to set the next set of things to discuss. Few more things before we start off with learning numericals on exponents. So I give special priority to negative numbers in every topic. Here the difference here is it is negative of 10 to the power of 4. Here it is negative 10 to the power of 4, whole to the power of 4. Here I would like to use the word whole, and here I don't use the word whole. So what is the difference? Negative 10 to the power of 4 is nothing but negative 1 into 10 to the power of 4, or negative 1 into 10 into 10 into 10 into 10. While negative 10 whole to the power of 4 is negative 10 into negative 10 into negative 10 into negative 10, right? 4 times. So here just the 10 is, the number 10 is getting multiplied 4 times. Here negative 10 is getting multiplied 4 times. That's the difference. Now there is a small variation again. The next one over here. Again, all these are something that you need to understand and keep in mind. A into B whole to the power of here I use the word whole. Here it is a into b square. Here I can use ab whole square. I can use that way also here, and I can use a into b square or to the power of 2. So the point here is I'm using the word whole over here and not so here, right? So what does that mean? Let me write it down. AB whole square means AB has to be multiplied 2 times, the first time and the second time, while AB square is A into B into B. Okay, very important difference. You guys need to understand this. Okay, next point here is sometimes the final answer might be same. See, just because the final answer is the same does not mean what you represented means the same. I'm going to explain that with this example. -9 whole to the power of 3, which is nothing but -9 into -9 into -9. So what is negative into negative into negative? Odd number of times I'll get negative 81, 729, right? Now -9 to the power of 3 is nothing but -1 into 9 to the power of 3, which is nothing but -1 into 9 into 9 into 9. Which 2 is the same answer, but what we started off with is not the same. Okay? Again, please be careful when it comes to negative. Having a bracket, not having a bracket, right? It makes a huge difference in exponents. Of course, not only negative, here we saw in the second example here that having a bracket makes a big difference over here as well. Okay. Now we are looking at when we have power to the power as 0. So till now it was always been either positive integer or negative integer, but not 0. So what does it mean? What does something raised to the power of 0 mean? Any natural number or a negative integer raised to the power of 0 means 1. -10 to the power of 0 also means 1. Right? 1000 to the power of 0 means 1. 1 to the power of 0 also means 1. Okay? Then 10 to the power of okay, 10 already we are done. Any variable to the power of to the power of 0 also means 1. So 0 to the power of 0, infinity to the power of 0, that is something which you will not handle. So it's undefined as per the Western mathematics. So those are undefined. But yes, any other number with either positive or negative will result in 1 when it's raised to the power of 0, that is. Okay, this you need to remember. Next topic, what is the power on a number? Okay, on a number, that is, if I have 4 or 2 by 3, 6 over here, 3 over here, do they have any power? Well, they do have power, that is 1 and 1. If not, 2 by 3 whole to the power of 1. Both are 1 is the same. 6 to the power of 1, 3 to the power of 1. So all of them have the power of 1. Right? Quite a few different things that we are doing. But yes, all these are introductory part. Once this is over, then the next part is quite simple. So a minute again. Let me show you the next thing which we are going to discuss. The next thing is representing multiple numbers. So till now we had single number, right? We handle single numbers. What if we have multiple numbers? How do you represent it exponentially? Quite simple. Again, everything in maths is simple. The basics are very simple. So, but understand it really well. So if I have to express this particular expression in exponent form, all I have to do is group the numbers which are the same, like -3 and -3, 4 into 4 into 4. So all you have to do is end up with -3 whole to the power of 2 or square into whatever the symbol is, just copy that, 4 cube. That's it. On the same line, the next question is 2 cube divided by 5 square. That's it. Right, try the next question out, next two questions. So we have a into a into a, that is a cube, into b into b, that is b square. Let me add one more question to you guys. Next one, I add one more question over here. So we have, see, it's here we saw that they are continuous, but here I am trying to keep it apart. But even then, because of commutative property of multiplication, we can take it as a cube and b as b cube. That's it. Okay. So here I have a combination of numbers and variables. Please pause and write all of it. So here you have 2 cube into p cube. Done. Now again try the next two questions. Yes, it's kind of confusing, right? 31 and -31, what to do? See, we clearly know that 31 is not same as -31. So you can think of 31 as some number altogether which is different, and -31 as some other number, like you can consider this to be 11 and this to be -31 itself. So if that was the case, you guys would have written it as what? 31 to the power of 1 into -31 to the power of 4. Right? So please understand the difference with negative and positive numbers. Very important. The last question. -4 to the power of what? Yes, 3 into 4 square. Okay, so this was the introductory part. We'll be doing few questions, and post that we'll start off with loss.